Looking at the graph of f of x and point 1 comma 1 on the graph, it is obvious that the graph of the function is the parent function f of x equals x squared. So we write our function f of x is just x squared. And when x is 1, then y is also 1. You can see the point 1, 1 is there. And then you can choose another point here which is 2 comma 4. If you plug x equals 2, then y equals 4. Now the second graph, which is the transformation of f of x, and we can also see that the graph has reflection because it is going down now. The vertex is max, but in this case your vertex is minimum. So we have reflection on x-axis, and also you can see the vertex 0, 0 has transferred to 1, 3. So then easily we can say our gx function will be x minus 1 squared plus 3. And since we have reflection, we can put a negative in front. So when you put a negative in front, then everything works fine. You can just see when I have x equals 0, when I plug it here, I get negative 1 plus 3, which is 2. So that works here exactly. So we are actually done with g of x. We got our function. We have our second example. In this example, we are saying that we are given a point 1 comma 2 on the function of f of x. Now g of x is 3 times f of x minus 1 plus 4. So what will happen to this corresponding point on gx? If you look at here, you can easily see that the graph is vertically shifted 4 units up, and then the function is also going 1 unit to the right. So then x value this will be increased by 1, and at the end we also see the function has vertically stretched by a factor of 3. So then what we do, we multiply this y coordinate by 3, which is 6, plus 4, that will be 10. So the point actually you are seeing 1 plus 1 is 2, and then 3 times 2 plus this 4 will make it 10. So you can easily understand the point 1 comma 2 on f of x becomes 2 comma 10 on g of x. So let us write this. So that exactly we got. So 1 comma 2 on f of x, and then it is going 1 unit to the right, so that's why we write 1 plus 1. And then y coordinate is stretched by a factor 3, so 3 times 2, and then further it goes 4 units up, so you add 4. So you got a point 2 comma 10 on gx. I'm taking another example so that f of x is x squared plus 1, so that when I say x equals 1, then y equals 2. So this is the point 1 comma 2 will be on the function f of x, which is x squared plus 1. Now we are doing the transformation like this: 3 times f of x minus 1 plus 4. So that means my f of x minus 1 will be replaced now by, let me show you detail, just like this. So that f of x is x squared plus 1, so f of x minus 1 will be x minus 1 squared plus 1. And now we see on the graph, I'm typing my f of x is x squared plus 1. We'll verify that 1 comma 2 is the point on this, and then 2 comma 10 will be the point on this, and then you graph it. So you can see this is my f of x, and the one inside that is my gx. So let me trace at 1, x equals 1 gives me y equals 2, that you can see clearly. Next, I'm going to the second graph. So my second graph is number 2 here, which is gx. And let me put x equals 2, and I'm expecting y equals 10. See exactly. So that was the transformation. So this question number 2 and question number 3 are closely related. And I'm done. I hope you have understood the transformation.